S. Sasidevi, Assistant Professor, Department of ECE, Knowledge Institute of Technology, Salem. Today we are going to see the embedded system and IoT design. In this, first unit is 8-bit embedded processor. 8-bit embedded processor consists of 8-bit microcontroller architecture, instruction set and programming parallel ports, timers and serial port, interrupt handling. Before going to the subject, we have to know about the what is microprocessor. Microprocessor is nothing but it is an important part of a computer architecture. Without we cannot able to perform anything on our computer. Microprocessor, for example, Intel Core is the one of the microprocessor. In simple words, a microprocessor is a digital device on a chip that can fetch instructions from memory, decode and execute and give results. Next, what is microcontroller? Microcontroller is having internally it consists of the oscillators, analog to digital converter, RAM, microprocessor and program memory and peripherals. This is the main difference between the microprocessor and the microcontroller. The exact definition for microcontroller is microcontrollers are widely used in embedded systems such as home appliance, automotive systems, medical devices, and industrial control system. They are also used in consumer electronics products such as gaming systems, digital cameras, and audio players. Microcontroller is a small computer on a single integrated circuit that is designed to control specific tasks within electronic systems. It combines the functions of central processing unit, memory, and input-output interfaces all on a single chip. Next, the main application of the microcontroller is home automation, consumer electronics, automotive systems, medical devices, industrial automation, smart grids, wearable devices, traffic light control, and agricultural automation. These all are the main application area of the microcontroller. Before going to the difference between microprocessor and microcontroller, generally embedded system. An embedded system is a microprocessor based computer hardware system with software that is designed to perform a dedicated function either as an independent system or as a part of a large system. Now we are going to see the difference between microprocessor and microcontroller. Microprocessor is the center of a computer system and microcontroller is center of an embedded system. In microprocessor, we have a separate memory and IO components, but in microcontroller, it is inbuilt, that is internal to it. Then, and microprocessor is a large circuit and microcontroller is a smaller circuit. Cost wise, the microprocessor has high cost and microcontroller is lower cost. In microprocessor, RAM, ROM, and other peripherals are absent, that is external to microprocessor. In microcontroller, RAM, ROM, and other peripherals are present. Microprocessor has high speed. Speed in microcontroller, speed depends on the architecture. And generally, microprocessor is complex and expensive. Microcontroller is simple and affordable. Next, types of microcontroller. We have many types of microcontrollers. Basically, we have a 8-bit microcontroller. After some time, 16-bit microcontroller and 32-bit microcontrollers. Also, we have a ARM microcontroller and PIC microcontroller. Peripheral interface controller, and also having a AVR microcontroller. It is manufactured by the Atmel Corporation and commonly used in applications such as robotics, industrial control systems, and consumer electronics. This is the 8051 microcontroller architecture. In this architecture, we have many blocks: interrupt control, on-chip ROM and on-chip RAM, and timer blocks, and serial port, input-output ports, bus control, oscillator, and CPU. We will see one by one. First, we will see the CPU. CPU is nothing but central processing unit. It acts as a mind of any processing machine. CPU manage the different types of registers available in 8051 microcontrollers. Then we are moving for interrupt. Interrupt. When an interrupt occurs, the ongoing task stops. The subroutine for the interrupt is executed and then the previous job resumes. It will handled by the microcontrollers. It is the main task for the microcontroller. It is based upon the priority, highest priority request for execution. In this we have a timer 0. TF0 is nothing but timer 0 overflow interrupt. TF1 is nothing but timer 1 overflow interrupt. INT0 is external hardware interrupt. INT1 is external hardware interrupt, and RI/TI is serial communication interrupt. Next we are moving for memory. The memory is the main part of the microcontroller. For any data manipulation to occur, we require a set of instructions. These programs need to be saved in memory. This memory where the programs resides in the controller's memory is called code memory or program memory. In the 8051 microcontroller architecture, the microcontroller has 4 KB ROM and 128 bytes of RAM. Then stack. Generally, the stack operation of storing the data in a stack is known as push, and getting it back into a CPU register is known as the pop. These two conditions are in stack. It working on the principle of first in, first out. Next, the bus. Bus is a group of wires. Communication within the microcontroller happens through this bus. We have a two buses, address bus and another one is data bus. Address bus is only carry the address, and data bus carries the datas. Then we have an oscillator. The microcontroller requires a clock to perform operations. In the 8051 microcontroller architecture, we have an oscillator that functions as a clock for the CPU. And I/O ports. We connect other input and peripherals using these ports. Next, we have serial port, communication interface that enables the serial data transfer between the microcontroller and external devices. At last, we have timers. They are each 16 bits. We have two timers, each having the 16 bits. We have the timers to generate the gaps between the two events. Next, features of the 8051 microcontroller. It has 128 bytes on chip RAM and 4 kilobyte on chip ROM. It is program memory and 16-bit address bus. It is unidirectional and bidirectional 8-bit data bus. It has two 16-bit timers and having the 4 8-bit input and output ports, 128 user-defined flags, 16-byte addressable RAM. It also has two external and three internal interrupts. These all are known as the features of 8051 microcontroller. Next class we will see about the pin diagram. Thank you.